Today. Today's Tuesday. Right now it's Monday for me. And I am not here today to finish your lesson on solving trigonometric equations because I am taking care of some professional development today. So my agenda for the day is to go over yesterday's check. It did not go in for a grade on Power School, but I want you to see where you went wrong so you can learn how to improve your results for next week's test. And then we're going to do some real-world problems, which you've already seen these problems before. I'm just going to solve them on the video. Homework, finishing up the packet. It's raining real-world problems. Those will be the sections that you can complete this evening. Please remember your test is covered next Monday and Tuesday. All right, first question missed on the check-in was this guy right here. Actually, all three of them were great. When I'm given this restriction over here for x, this is implying to me that I'm looking for fundamental solutions. Okay? This entire check was focusing on solving using factoring techniques. When I see this expression, I'm seeing 1, 2, only 2 terms. The only method that I know how to use currently with 2 terms for factoring is called the GCF method, the greatest common factor. So something that both of these 2 terms have in common is a cosine. So I'm going to pull cosine of x out of both of these 2 terms. Okay? When I pull it out of my first term, I'm left with 2 times cosine of x. Because notice this first term was being squared, so there were 2 of them. My second term, when I pull out the cosine, I'm only left with minus root 3. When you are solving by factoring, your job is to set both of your factors equal to 0. So the first one I set equal to 0 is cosine of x equals 0. And my second one, 2 cosine of x minus root 3 equals 0. So my very first one, cosine of x equals 0, this means I'm needing to be thinking about my quadrantal values. Because I'm remembering that cosine is implying the x-coordinate on my unit circle, which means that I'm located either up here or down here. Okay? So, possible solutions here, we have pi over 2 and 3 pi over 2. Both of these values obey my restriction. All right, what about this guy over here? We're going to add root 3 on both sides, and then we're going to divide everything by 2 in order to isolate our cosine. So we get cosine of x is equal to positive root 3 over 2. Things I'm thinking about. I'm noticing that cosine is equal to positive root 3 over 2, and cosine is positive in the first and the fourth quadrant. Okay? To have a cosine value of positive root 3 over 2, I know that I'm thinking about my 30-degree reference angles, so I'm thinking about pi over 6. And I'm thinking about my 30-degree reference angle in my fourth quadrant. Now, a lot of you wrote negative pi over 6, but negative pi over 6 does not obey my domain restriction, and so what I think about is my other value of 11 pi over 6, who's also located in the fourth quadrant and obeys my domain restriction. So my answers that I should have seen for the very first problem, I should have 4 answers. We have x equals pi over 2, 3 pi over 2, pi over 6, and 11 pi over 6. To get full credit for this problem, which I did not mark your score, you will need to show all 4 answers as well as how you solve it. All right, the second question. I'm noticing that I have 3 terms. And therefore, I'm probably going to need to factor a trinomial, but I should probably get this set equal to 0 first. I'm also making other observations. As you can hear, it is a school day currently. I'm using my lunch right now. Because I have a domain restriction, again, I'm implying to you that we are looking for fundamental solutions, bounded between 0 and 2 pi. When we did this type of problem in class, we tried to relate this back to being a value. We're letting a represent the sign of x. Okay? It kind of makes it look a little less intimidating. So when I go to factor this, I have an a value of 1, so I know I'm having a and an a. I need to multiply to be negative 2 and add to be negative 1, so we're going to have a minus 2 and a minus or plus 1. Because negative 2 times positive 1 gets me negative 2. And then if I add negative 2 and positive 1, I get negative 1. Okay? But let's remember that we're really using sine of x. And so what we're going to do is we're going to set each of our factors equal to 0. So a minus 2 equals 0. 1 equals 0. We start to solve, and we get that sine of x equals 2. Well, our sine curve, if you recall, is bounded between 1 and -1. Therefore, this does not produce a solution. There are no solutions produced in this one over here. When I start to solve for this guy, subtract 1. So we're looking for where we have a sine value of -1. Please recall that sine refers to your y-coordinate. And so I have a y-coordinate of -1, and that only occurs down here, located at 3 pi over 2, which again is contained in my fundamental restrictions. Therefore, the only solution that I should see on your paper to get credit is 3 pi over 2. But I should see all the work leading up to this. So in the very first problem, we factored by using the greatest common factor. In this problem, we're solving by factoring a trinomial. In our third problem, we're factoring using a technique, which I'm hoping you remember, called grouping. Okay? Notice the slightly different phrasing from that included in your homework. When I ask you to solve an equation in full generality, I'm asking that you write general equations that would help me find all the different possible solutions. So if I'm solving by grouping, I'm noticing that my first two terms look kind of similar, and they have something in common. So I'm going to pair those terms together, and I'm going to factor out what they have in common. Together, they have 3 tangent squared of x in common. And then I would be left with, when I take 3 tangent squared of my first term, I'm only left with tangent of x. When I take 3 tangent squared of x out of my second term, notice he's negative. So I'm left with -1. Okay? When using grouping, the goal is to get a common factor between your pairs. So I'm going to make a pair with my second two, but notice that they look kind of the same. So what I'm going to do is I'm going to pull out a -1 from these two terms in order to create the inside components the same. Okay? So now, like I said, notice those two interior values are the equivalents. That's a good sign. So what I'm going to have for my factors, since they both have this in common, he's one of my factors. And then I'm going to pull what their coefficients are and create another factor. So we have 3 tangent squared of x minus 1 as another factor. Per usual, to solve these equations, I'm going to set my factors equal to 0. So then we got 3 tangent squared of x minus 1 equals 0. And then we have tangent of x minus 1 equals 0. I'm going to solve the right-hand one first. It looks a little bit easier. So we're going to add 1 to both sides. So we have tangent of x equals 1. Okay? So I'm thinking about where am I positive tangent. So here's my quadrants. I know tangent is positive in the first quadrant and at the fourth quadrant. Okay? Well, where do I have tangent values that's equal to 1? That would be all my 45-degree referencing. So in the first quadrant, I have pi over 4. In the second quadrant, I don't have any guys. So then I jump to the third quadrant, where one of my solutions is 5 pi over 4. Because I'm creating general equations, we're going to have x equals pi over 4 plus, now here's where a lot of you went wrong. Notice we're dealing with tangent of x. The period of tangent of x is a period of pi, so therefore we're adding pi k. Think about it. We don't actually need an equation for 5 pi over 4, because when I add pi onto pi over 4, it's going to get me this same solution of 5 pi over 4. So the only solution necessary from solving this side is this guy right here. Now what about this one on the left-hand side? Obviously we're going to add 1 onto both sides, divide by 3, so then we have tangent squared of x is equal to 1/3. Okay? Next thing I'm going to do is I'm going to take the square root. Please remember that when you take the square root of a quantity, you must always place a positive or a negative in front. The square root of 1/3, hopefully you're remembering that simplifies to root 3 over 3. Because I'm dealing with positive or negative root 3 over 3, that actually means that I could be represented in all 4 quadrants. So things I'm thinking about. Who has the tangent value of root 3 over 3? Hopefully you're thinking that's my 30-degree reference angles. So we have pi over 6 located in the first quadrant. We also have 5 pi over 6 located in the second. We also have 7 pi over 6 located in the third. And then in the fourth quadrant, we're going to have, I can do math, I promise, 11 pi over 6. All right, so these would be our fundamental solutions, but we need to create general equations. All right, so let's first use pi over 6. X equals pi over 6 plus, remember, the period I'm dealing with is a period for tangent, so we have pi k. Because when I'm shifting over by pi units, I don't need to write one for 7 pi over 6, because pi over 6 plus pi gets me that. However, when I add pi, I skip over 5 pi over 6, because they're not pi units apart, so I must also write an equation that x equals 5 pi over 6 plus pi k. So what I have boxed in, these three general solutions, are the three general solutions that I would need to see on a test or a quiz in order to give you full credit for these problems. Okay? All right, so now we keep on going. So now we're going to move into real-world problems. Now, if you want to pause the video and try these yourself, that's great. In fact, I highly encourage it because you've already seen these problems in your homework during the modeling. So if you want to pause me, please feel free. All right, so now I'm going to go over these problems. So here's the Ferris wheel problem. Notice in the modeling packet, though, I had you analyze the equation in order to write it. So this question, I'm given the equation. It says find the first 4 times when you will be 30 feet above the ground. If I'm looking for when I'm going to be 30 feet above the ground, I'm giving you my value for h. I'm giving you the height to plug in. So then we have 30 equals 20 times cosine of pi over 4, t minus 3, and then plus 23. Per usual, we're still trying to isolate our trigonometric function. So we're going to subtract 23 from both sides, and then we're going to divide by the coefficient of 20. Okay? So then we have cosine of the quantity, pi over 4, t minus 3, and then we have 30 minus 23 divided by 20, getting me 7/20. Okay? All right, so note, we have an expression that's cosine. It's equal to positive. So things I'm thinking about, cosine is positive in the first quadrant and the fourth quadrant. When I take cosine inverse of both sides, 7/20, okay, that's going to get me an isolated quantity of pi over 4, t minus 3. Okay? Your calculator, remember cosine inverse is restricted. Your calculator only gives you the solution for the first quadrant because that is what he has been restricted to. So therefore, my first quadrant solution would be 1.21. Recall with cosine, he's a little bit easier to manipulate than sine is. So what I can do is I can also have another solution of negative 1.21. Okay? So this is currently where we stand with solving this equation. So actually at this point, it'd be a lot easier for us to first write a general equation, which is part 2. So where I currently stand in my equation, I have 1.21 as an answer. Remember, because we're dealing with a cosine that's not been transformed, it's what this equation has been equal to, we're going to have a traditional period of 2 pi k. This is happening every 2 pi k units. This is going to be equal to pi over 4 t minus 3. Okay? And we're also doing this for the other version of negative. I don't have enough room here, so I don't even know why I did that. We'll just do that one in a second. Okay. So what we're going to do is we're going to divide all the quantities by pi over 4, and then we're going to add 3. And when I do that, I get an equation for t where I have 4.54 plus 8n equals t. Okay? When I do this for my other version, negative 1.21 plus 2 pi k equals, again, same quantity. I'm going to do the same thing. Divide by pi over 4, add 3. And then what we get for our solution in this case is 1.46 values of k equals technical difficulties today. So as I said, we need to plug in values for k. It makes the most sense for us to first plug in k as 0 because that's just going to leave us with our values of 4.54 and 1.46. Okay? So we know 4.54 was one of our solutions for t, and t equals 1.46 is my other one. Okay? Side note, why don't I plug in a value of -1 for my value of k? Well, that would cause me to subtract a period. And because my period here, I have a period of 8, both of those values would become negative, which means that they are not possible solutions. Ooh, really having technical difficulties. So to find the next solution, I'm just going to add 8, which is my period. aka I'm plugging in a value of k equals 1 to my general equations. So when I add 8, I get solutions of 12.54 and 9.46. Okay? So these are the first 4 occurrences of when I will be 30 feet above the ground. Alright, let's see if the other problem goes a little bit better. See if I don't have any issues. So this was the extraterrestrial problem from your modeling homework packet. Again, you didn't need to analyze the equation. I already gave you an equation. Some of you will notice that this one's a little bit different because I'm using a negative amplitude compared to what the solution key said. But both are perfectly acceptable solutions. Find all the times when the alien's temperature will be at its maximum. Okay? A few things I could do. I could solve this algebraically, or I could solve this one logically. Because I have a negative amplitude, I know that I'm starting at the bottom of my curve. Okay? Which means that my phase shift over here of 15 is occurring here. Okay? This is my shift. This is where I'm hitting my low value, 15. Now I need to figure out my period. So my b value is pi over 20. Okay? We have 2 pi divided by my b value of pi over 20. That gets me really 2 pi over 1 times my reciprocal of 20 over pi. Pi's cancel out. So my period is equal to 40. So the next time that I'm going to hit a minimum will be 40 units from 15. So my minimum will occur at 55. But that is not what this question was asking for. It was asking for maximums. So if minimum to minimum is 40 units, maximum to maximum is only 20 units. So therefore, the very first occurrence where I hit a maximum is 35 because that's 20 units away from the very first minimum. Because this question says find all times, however, what this is implying is that I need to create an equation. Okay? So x equals, the very first time I hit my max is 35. Now, when will be the next time that I hit it? Well, that's just going to be a length of the full period. Okay? Now, my period is 40, so I'm going to have an equation of plus 40k. So x equals 35 plus 40k. Again, could you do this one algebraically? Absolutely. But why not use a little bit of logic? Because we've already seen problems like this. Last solving problem, and then we are done with this unit. All content will have been finished prior to break. So I have an equation, and I need to find all the times when I'm going to be 110 degrees, aka general equation. I'm giving you my temperature, so I'm telling you what to set the equation equal to. So 110 is equal to -8 cosine of pi over 20, and we got t minus 15, then plus 112. Okay? We start to solve this, we're going to subtract 112 from both sides, divide by -8, and we're going to get 1/4 is equal to cosine of, let's let our substitution technique get practice. Let's let this guy here be x. So 1/4 of something. 1/4 equals cosine of x. Note, cosine is positive. That occurs only here and here. When I evaluate cosine inverse of 1/4, the solutions that I get for cosine inverse of 1/4, well, my calculator only gives me 1. Again, due to the restrictions of the inverse function. And the other solution that I obtain from this guy here is -1.32 because they are both in quadrants where cosine is positive and they have the same reference angle. Now this solved for x, okay? What we're really solving for is that inside quantity. So let's first create general equations the other side. Okay? So we're going to divide everything by pi over 20. And then we get t minus 15 is equal to 8.4 plus 40k. Notice that 40k, if we had just decided to find the period, that's what we would have found. And then all we need to do is add 15, so then 8.4 plus 15, we get 23.4 plus 40k. Here's one of my solutions. My other solution, where I'm using a negative 1.32. The only thing that will be different is this value 8.4. So we're going to have t minus 15 equals, so negative 1.32 divided by pi over 20 is going to be negative 8.4. Again, still plus 40k. And then again, last thing to do is add 15 to both sides. And congratulations, once you have written down that negative 8.4 plus 15 gets me 6.596 plus 40k. You have just finished our third unit of pre-calculus. So now we have the ability to add possibly more names onto the wall of champions. May you have a good rest of your class period, because if you notice, you should have maybe some time left over to work on your homework this evening. Have a good one. Ooh, how do I stop this?